Okay, welcome to Lesson 11, Definition of Congruence and some Basic Properties. Lesson 11 starts a new topic in Module 2, Topic C, and we're going to kind of shift gears a little bit. We have been practicing finding basic rigid motions that would map one figure onto another. We've explored a lot of the properties of the basic rigid motions and perform them with our transparencies. So now what we want to do is use what we've learned to come up with a definition of congruence. So we're going to define congruence as being, if I can find a sequence of motions, of basic rigid motions that would map one figure onto another, we'll be able to say that those two figures are congruent. We're going to use a symbol for that, and it's right here, the congruency symbol. So let's start with a simple example, one that you've done quite a bit with. Here's two triangles, A, B, C, and A prime, B prime, C prime. And I know you're getting pretty good at this, and so we could find a sequence of motions, basic rigid motions, that would map these two together. I'm getting a lot of glare here. So we could, for instance, define this vector CC prime. We could translate triangle ABC along vector CC prime. And then we could rotate triangle ABC around center C, a certain number of degrees, D degrees, until, and we could say until CB, segment CB, coincides with C prime, B prime. Okay, so then we've got ABC mapped onto A prime, B prime, C prime. And if we can do that, we're going to be able to say that, therefore, triangle ABC is congruent to triangle A prime, B prime, C prime. And it's congruent because we found a series of basic rigid motions that maps one onto the other. Okay, so this is going to be a big idea in geometry, that we can use these transformations to prove congruency, because we know that measures of segments and measures of angles are all preserved on these rigid motions. Okay, so let's go back to exercise 1, and we will work on that together here. Okay, just one more minute before we start exercise 1. Going back to this exercise we just did, or this example, we mapped ABC, triangle ABC, onto A prime, B prime, C prime with a series of basic rigid motions. So will it always be true? And by that we showed that triangle ABC is congruent to A prime, B prime, C prime. Can we always get back the opposite direction? And that's a question. So if this is congruent to this, will this be congruent back again? And it seems reasonable that it would be. But we know that sometimes the order matters when we do these sequences of transformations. So the question that's really kind of left to proof is, can we undo it? And the answer to that is yes. But let's look at an example that I've written out for you here. So I've got figure S mapping on being translated by a vector here and reflected across line L giving me S prime. So it's pretty maybe clear to see that, and so that gives us this first statement here. So that therefore S is congruent to S prime. There is a congruency that maps S onto S prime, and it is a translation followed by a reflection. So what is the congruency that would map S prime back onto S? Well, it would be the opposite, right? It would be reflecting and then translating, but translating by the opposite vector here. So there is a sequence of basic rigid motions that goes in this direction as well. And that tells us that S prime is congruent to S. So what we can, and if we threw rotations into this mix, we would also find that we would be able to undo those rotations to get back to our original figure as well. So what that tells us is that the order doesn't matter when I write these congruency statements. That if S is congruent to S prime, then S prime is also congruent to S. So we'll use that maybe a little bit when we do this exercise 1 now. So go ahead and work on exercise 1 and see if you can find the sequence of basic rigid motions that shows that S1 is congruent to S2. So this is being asked a little differently now. We're being asked, not being told just to map S1 onto S2. You're being asked to use the basic rigid motions to show congruency. It's the same thing, but it's just worded a little bit differently. Okay, so I would start by naming a couple points here. So let's name A and B so that I can draw a vector. And I'm going to draw vector AB. So I'm going to move this up a little so we can see. So I'm going to translate S1 along vector AB. Okay, and that will bring me right up. I'm just going to kind of freehand this, bring me up right around here, the figure up there. So I've translated figure S1 along AB. Now I want to rotate, and I'm going to actually draw the angle of degrees. So I'm going to go from here to here. I'm going to call this D1 because we're going to have 3 of these by the time we're done. So I'm going to rotate D1 degrees around center B. Okay, once I do that, I'm going to have this, the long side of my figure is going to coincide with this long side of S2. And so then I'm going to, you see what I'm going to do next, I'm going to reflect. And then I'm going to reflect across the long, the long side of the figure. Okay, and that would map S1 onto S2, and so I've shown that S1 is congruent to S2. Okay, exercises 1B and 1C are very similar. So go ahead and do those, come back and we'll check them together. And again, you're looking for a sequence of basic rigid motions that will show that one figure, in this case, S2 is congruent to S3. Okay, so go ahead and pause and then come back and we'll do these. Okay, so I would do this one in a very similar way. Let's go ahead and call this, we're going to use AB, so we'll go C, or no, we called this B, so let's call it B again. This is B, we'll call this C. Let me get it to match up again here. Okay, and I'm doing that so that I can name my vector to translate along. So I'm going to translate along vector BC. And I'm translating, I should put in what figure I'm translating. Translate S2 along vector BC. Once I get it there, I'm going to have to do a rotation. So let's draw what my figure looks like. It's got the long side here, like so. So, draw that a little better. Okay. Okay, so there's my figure in the middle. So I've translated along BC, and I'm going to rotate. So let's draw the angle of rotation. So I want this side, this long side, to line up with this long side. So my my angle can be seen right here. So we'll call this one D2 since it's our second sequence of basic rigid motions. So that's my angle there. So I'm going to rotate around center C. D2 degrees. Okay. And once I do that, I've got it mapped. It's done. So it's a translation followed by a rotation, and that's going to establish that S2 is congruent to S3. I've got that going on. Okay. Okay, so here is exercise 1C, and in this exercise, we're looking for the sequence of basic rigid motions that's going to map S1 onto S3 because we're trying to show that S1 is congruent to S3. So again, we called that point A. This is point C. We're going to have a vector here. We're going to let there be a vector. Change my label here. Here's point C. All right, so we've got vector AC. So we're going to translate S1. Translate S1 along vector AC. That will be our first motion. And then that's going to be, let me use a different color for this one. That'll put us right over here in this area. So there's our intermediate step. So we translated S1 along AC, and that's what we came up with. And then we need to rotate, and so we can go either direction. We can either come this way or we can go that way. I'm going to draw it this way. So I want this to come all the way around to here. So this is D3, our angle of rotation. Then I'm going to rotate D3 degrees around center C. C is our center again, around center C, and that's going to make these two long sides match up. And this time I'll have to do a reflection again. And then I'm going to reflect across the long side of figure S3, I can say. Oops, move it up here for you. Okay, and then we'll be done. And so we've shown that S1 is congruent to S3. Okay, let's see if we can move this all together. I want to keep this together. So we showed in 1A, we showed that S1 was congruent to S2. And then in 1B, S2 is congruent to S3. So some of you might have been saying, why are we doing all this work of showing that S1 is congruent to S3? Because if we know that S1 is congruent to S2 and 2 is congruent to 3, then for sure S1 will be congruent to S3. But we went ahead and we showed that there was a sequence of motions that would do it. So we kind of proved this one two ways, okay? Okay, so we've seen in previous lessons that the basic rigid motions map lines to lines, rays to rays, segments to segments, and angles to angles, and preserves measures, the lengths of segments and the measures of angles. And so what we, and we've also talked about that this could be true for sequences of basic rigid motions. So doing one after another, not just two, but maybe 3 or 4 or 5. Will we still have those properties of the single basic rigid motion? And we found that we do. Exercise 2 can just help you prove that one more time. So this says, perform the sequence of a translation followed by a rotation of figure XYZ, where T is a translation along vector AB and R is a rotation of D degrees around center O. Label the transformed figure X prime, Y prime, Z prime. So I'll just do that. You can do it too. I'm going to trace my, figure here, XYZ. I'll trace my vector, AB. And in the previous exercises, I wasn't always drawing the intermediate figures, but you should be. For instance, so your exercise 1C should look something like that, showing the transformation, the rotation, and the reflection, or rather the translation, the rotation, and the reflection. You can draw the intermediate steps. I'm going to on this one. Okay, so we are translating along vector AB. So let's do that in the direction of AB. I'm going to draw my intermediate figure here. This isn't my X prime, Y prime, Z prime yet. It's right here. It's not pretty, but it is what it is. Okay, so now what I want to do, I've got center O that I'm going to rotate around, and I can go any amount I want, so I don't need to mark anything. So I'm going to go in let's go clockwise. I'm going to go clockwise over to here and trace my figure again. Get pretty good at this. So that's our transformed figure there. And so the vertex here is x, so this is x prime, and let's see which one. This is z, so this is z prime, and this would be y prime as we rotated it around. So there's our transformed figure. So will xyz be congruent to x prime, y prime, z prime? Well, it will, because we used a sequence of transformations to get there. So all the measures are preserved, and you can tell that these two are the same size and the same shape. Okay, so let's go to the lesson summary on your problem set. It's right after the exit ticket. And it states that given that sequences enjoy the same basic properties of basic rigid motions, we can state three basic properties of congruences. So a congruence is a sequence of these rigid motions. So we'll call this congruence 1, or C1. A congruence maps a line to a line, ray to ray, segment to segment, angle to angle. Okay. Preserve lengths of segments and degrees of angle. And as we said before, the notation that we're going to use for congruence is the equal sign with the squiggle above it. And it just means is congruent to. So that's what we've shown in this lesson. So you have a problem set to do. I'm going to point out to you the very first one here. Could be a little tricky. So if you don't quite get this one, go to the answer key and see what you can do. It turns out, it says, given two right angles with the lengths shown below, is there one basic rigid motion that maps one to the other? And if there is, what is it? And it turns out that there is one motion that will map one onto the other, but it might be kind of tricky to find it. So hunt for it. If you can't find it, just check the answer key and see what they have to say. The rest of them, I think, should be pretty straightforward for you. Here talks about mapping, showing two rays being congruent. So but I can do that. I can transform a ray just like I do any other figure, a triangle or a point or whatever. So so work on those, and yeah, I think you'll be good. So don't forget to do the exit ticket before you do the other and have it checked. And try to be as precise as you can as you're describing these congruencies. All right. Good luck with that.